Welcome to the session number 20 from the playlist of laws of motion. The topic is constraint motion, and this session is in continuation of the session number 19. So, in this session, I have taken one question which is written on this board, and this is the figure which was provided along with this question. The question here is the acceleration of the block A is 2 meter per second square towards the left as indicated by this arrow. The acceleration of the block B is 1 meter per second square. This is the block B, and the acceleration of this block is 1 meter per second square towards the left. The acceleration of the block C is to be calculated, or we have to find the acceleration of the block C if the pulleys and the surfaces are smooth and the string is inextensible. So this is the string which is passing over these fixed pulleys, and this string is driving these three blocks. Now the block A is moving towards the left, the block B is also moving towards the left. So because of these two motions, this block C will be lifted upward, and it will move upward with a certain acceleration which I have taken here as AC. Now in this question, the I1, I2, I3, I4 and I5 are the different parts of the inextensible string, and here, irrespective of the motion of the block A and block B, the total length of the different parts of the string will remain the same. That is I1 plus I2 plus I3 plus I4 plus I5. So the value of the different parts of this inextensible string will always remain the same. Since we do not have any value, so I am just taking it as a certain value k, which will always remain the same. So here, if I double differentiate this equation, what I will be getting is that is d square I1 upon dt square plus d square I2 upon dt square plus d square I3 upon dt square plus d square I4 upon dt square plus d square I5 divided by dt square. This will be equal to 0. So what I have done is I have just double differentiated this equation. That is, I have differentiated this equation 2 times. So this d square I1 upon dt square, d square I2 upon dt square, d square I3 upon dt square, d square I4 upon dt square and d square I5 upon dt square are the respective acceleration of the different parts of the string. Now here I will be considering the acceleration as negative for those parts of the string whose length is reducing due to the relative motion of these two blocks. So here since the block B is moving towards the left and the block A is also moving towards the left, so the length of this I2 part of the string will increase. The length of this I4 part of the string will reduce. Since the block is moving upward, therefore I1 and I5 the length of this part of the string, that is I1 and I5, this will also reduce. So I will be considering the acceleration as negative for those parts of the string whose length is reducing, and it will be taken as positive for those parts of the string whose length is increasing. So now here d square I1 upon dt square is the acceleration of this part of the string, and here since the acceleration of this part of the string will be equal to the acceleration of this block C, so I will be writing here the acceleration of this part of the string as minus AC. Now I2, the acceleration of this part of the string will be taken as positive because the length of this part of the string will increase, and since the acceleration of this block A is 2 meter per second square, and so this string is connected with this block A. Therefore, the acceleration of this part of the string will be equal to +2. Now I3. This block A is moving with an acceleration of 2 meter per second square on the left side, and block B is also moving towards the left with an acceleration of 1 meter per second square. So the effective acceleration of I3 will be equal to 1 meter per second square, and this will be taken as positive. Now I4, the length of this part of the string will reduce, and therefore the acceleration of this part of the string will be taken as negative, and since it is connected to block B, so its acceleration will be equal to -1, and the acceleration of this part of the string, that is I5, this will be also taken as negative, and it will be equal to this minus AC, because the acceleration of this block is AC, and so I will be getting the equation, that is minus AC plus 2 plus 1 minus 1 minus AC, which is equal to 0. So here d square I1 upon dt square is equal to 2. This is equal to this minus AC. D square I2 upon dt square is equal to 2. D square I3 upon dt square is equal to 1. D square I4 upon dt square is equal to -1, and the acceleration of this part of the string, that is I5, this is equal to minus AC. Okay? So from this equation, the value of AC is equal to this minus 2AC plus 2 is equal to 0. So AC is equal to 1 meter per second square. So the correct option is A, and the acceleration of the block C is 1 meter per second square in the upward direction. So thank you very much for joining this session. In the next session, I will be continuing with the same topic, that is the constraint motion, but I will be coming up with some different type of a question. So till then, have a nice day. Bye.